Hi, my name is Nishant and I'm one of the trainers here for SAS. Now, I'm going to showcase the truncation functions in this video. So this video will be all about the truncation functions. Now, let me tell you what the truncation function within the SAS program does. It more likely works on the estimation, parameters. You can call it as the empirical values. So it actually truncates the numerical values that we have got. With us within any sort of data set that we are dealing with. So I'm going to showcase that to you, how it actually does, what are the inbuilt functions to perform those areas within this truncation application. Let's just see how it is useful, and it can be utilized for the analysis and the data processing purposes. So I'm going to run this program, which is for the truncation functions. Now let me just explain you how this looks like. So now this is data trunk function is what I've given this as to be named. This is how I've defined this data as. Now with this, I'm going to get the nearest greatest integer. Now I'm going to get this value with the help of the ceil. Now ceil is nothing but the inbuilt truncation function. You can say that this is the inbuilt function for SAS. Now with the help of ceil, we'll get to see what it gives us the output. This will actually give us the nearest greatest integer value as an output, and the similar goes with the floor as well. So we'll get the understanding of the difference as well once we get the output of both of these factors. Now with that, we've got the third objective with this set of data that we're going to deal with. Now this one will give us the integer portion of a number. So you can see over here that this is the 32.41. This is more likely a float figure. It's a floating figure. Now this will give me the output of the integer value of this entire number. That's what the int, the int, which is the inbuilt function. Again, within the SAS program, we've utilized that. And then finally, in the end, we have got the round value as well. So you can see the value is given is in the float figure, and the objective behind this program is going to be going to figure out that round of nearest value, or out of this figure is what we're going to do in here. So this is how overall you can see that this is actually truncating the numeric values, and it's more likely it's working on the empirical format. It's working on the estimation format. It's working on the nearest value format in this area. So I'm going to run this program to showcase the output to you, and we'll be able to get a much better understanding with the help of the output that we'll get here. So I'm going to hit F3. Now the moment I hit F3, I've got the output over here. Now you can see the ceil and floor. Let's just talk about the ceil and the floor. Let's get back to the code. Now with ceil, you can see the nearest greatest integer with this 11.85. So just when you say it's ceiling, it seals the upcoming highest value, which is on the upward side, which is on the moving direction. So that's why 11.85, the empirical value, or rather you can say the estimated value, which is the greatest integer, nearest greatest integer, we have got the output as in 12. Now when it comes to floor, now the difference over here between the floor and the ceil that you can see, it is also asking for the nearest greatest integer, but the output that we have got is 11. The only reason is because it takes the values in the backward direction. So now let's say if I just change it to let me just change it to 95, or rather let me just put it as 45. I hit enter, or rather I will hit F3. You can see the floor value is still 11 because it's actually going into the backward direction. Yeah, that's what we give this as to be the name of floor, because it takes the figure downwards and then figured out which is the highest, which is the greatest nearest integer value, because it does not moves on the on the moving. It doesn't go on the moving direction. Instead, ceil does that. So ceil actually goes on the moving direction. If you just change the value over here, if I just put it as 25, let's see the difference. It will give you the vice versa option. So it will still give you the seal value as to be 12. As we know, we've already seen why it does that, because it always moves into the moving direction, wherein the floor comes in the backward direction. So that's the biggest difference that you can always explain, that you can always talk about when it comes to the inbuilt function of seal and the floor. Then finally, moving on to the third set of code over here that we want to discuss about. Now this third set of code over here talks about integer portion of a number. So here we've got the number. Yeah, this number is in the float format. It's in the decimal format. You could say 32.41. Now we want this to give us an output in form of integer. So the integer value over here is nothing but 32. Now if you get back to results, you will find that 32 is the actual output that we have got for the integer value as a whole. Now if we just again go back to the code, and let's just talk about the last objective that we have defined over here. The last objective that we've defined here is to get the round off to the nearest value. Now over here you can see this figure is 5621.78. So the round off to nearest value, if you look into this result, you will find it has given us 5622, which is again following the empirical value format, the estimate format. Now I'll do a slight change here to show you how it changes the output. So instead of 7-8, I'll make it 4-8. So 4-8 again, which is less than 50, and making it closer to 5621 instead, making it closer to 5622. So let's see, how it shows the difference in the output. So I hit F3 to get the output. Now this time there should be a difference in the output. We'll just see that. We are expecting that to happen. Now you can see the difference. Now the output this time that I've got here is 5621. If you remember, the previous output was 5622. The only reason behind that was after point the value was 7-8. Now this time what I did is I did a slight change here, and I changed it to 5621.48. So the nearest value by default became 521, because its difference, it's just 0.48 away from 5621, wherein 5622 is now 0.52 away, and that's the reason why we've got the output as 5621 instead of 5622. So this is the beauty, this is the advantage, this is the smartness of the truncation whereabout that we work on the SAS program. So this is very useful when it comes to the probably you can say the data cleaning part, or it helps in data processing. Also it helps in analyzing the data and so on. It's very useful, very useful term. So this is how the code looks like. Very simple code. We have not done much in the coding aspect over here. We've just defined the data, we've given the inbuilt functions as the command, and finally we've given the command for the print out of the data, as in form of the proc print data is equals to trunc underscore functions, and that's what we have over here. And finally we have got the output in this form. And if you look into the output data, as the entire set is, the entire result itself is in data format. So yes, you've got all of that over here. All sort of output is given over here. So this is how it looks like. This is how it works. With very good interface, I would say. I must say that the SAS Studio makes it very easy for anyone to analyze the data, to work around the data set that you've got, and it gives you that edge, that advantage. You have this really great debugger as well that tells you where things have gone correct or where things have gone wrong. If you are If you encounter any sort of error, so this is the area where you can always come across that you can always come and check those notes, and you can check those warnings and errors and so on. And finally, over here it gives you the output data, it gives you the result over here, and the job is done. So this is all about the SAS truncation functions that we have to see, the SAS truncation functions program within the SAS programming. So thank you for watching this video. Thank you for listening in to me. Thank you once again. Thank you.